Ever get that spinning wheel of doom? You know the one, when you're trying to load a website.
Yeah.
Happens to all of us. Well, today's deep dive, we're going to pull back the curtain on how the internet actually works.
I think everyone takes for granted, I mean, I do, the fact that we can, send cat videos and have meetings across continents. It's amazing.
Appreciate that next Netflix binge even more, am I right? But, right, so how does it work? We're diving into TCP/IP. It's the protocol suite that makes all that possible.
Right.
We've got some excerpts from this technical document. It was originally in Portuguese, called Arquitetura TCP IP 2.pdf.
Okay.
We've translated it, obviously, and broken it down for you.
By the end of this deep dive, you'll be able to, impress your friends, with your internet knowledge.
Right.
Or at least understand what your IT department's talking about.
That's the dream. That's the dream.
Right.
Okay. So the document starts with the building blocks, networks, specifically WANs and LANs.
So imagine a highway system, right?
Okay.
That's your WAN, your wide area network, connects cities and countries, lets data travel, vast distances. Now picture the roads within a single city.
Okay.
That's your LAN, your local area network. So connecting devices, but within a smaller area, like a home or an office.
Okay, so we've got our data highways and our local roads. What about the cars on those roads? How's the data actually traveling?
So think of Ethernet and FDDI as two types of cars on those roads. Remember those thick coaxial cables?
Oh, yeah.
That was early Ethernet. These days, Ethernet's kind of traded in that clunky cable for the more common twisted pair wiring. You probably have it at home. Both Ethernet and FDDI, you'll find those in offices and campuses, but Ethernet's the more popular choice now.
Faster and cheaper, always a winning combo.
Exactly.
Our source also mentions ATM. It sounds like it's in the fast lane.
ATM, or asynchronous transfer mode, is like the super fast train of the networking world. It uses special high-speed lines, fiber optic cables to handle, data-heavy tasks.
Things like high-quality video calls and stuff.
You got it. So while Ethernet's great for, everyday browsing and file sharing, ATM steps in when speed is critical.
Makes sense. So
Yeah.
we've got our networks and the ways devices connect to them. Let's talk about TCP/IP itself.
Yeah.
The document describes it as a layered model.
Layered model. Imagine a well-organized team. Okay. Each layer has a specific job, and they all work together to make sure your data gets from point A to point B reliably.
Okay, I'm intrigued. Break it down for us.
All right, so at the top, you have the application layer. This is where you hang out. Email client, your web browser, your apps.
So that's the user-facing stuff. What's happening kind of behind the scenes to make it all work?
So below that is the transport layer. This layer sets up a connection and manages the actual flow of data between applications. It's like the postal service making sure your package gets to the right address.
Okay, so we've packaged up our data. Where does it go next?
That's where the internet layer comes in. IP is the star player here. This layer is all about addressing and routing, like the navigation system in your car.
Okay.
Making sure your data gets to the right destination.
So it's like the internet's GPS.
Exactly. And finally, we have the network interface layer. This layer deals with the physical hardware of the network, so like your Ethernet card or your Wi-Fi adapter.
So it takes those ones and zeros and transmits them over the physical wires or radio waves.
You got it. And each layer depends on the one below it, and it creates this really robust system for sending and receiving data.
And within that transport layer, we've got UDP and TCP, which are two very different approaches to data delivery. It's like choosing between a postcard and a registered letter.
Right. Think of UDP like sending a postcard. It's fast, it's efficient, but there's no guarantee it'll arrive or arrive in the right order. TCP, on the other hand, is like that registered letter. More reliable, you get a delivery confirmation, but a bit slower.
So UDP is great for speed, like streaming a live video where a few dropped packets won't ruin the experience.
Yeah.
But TCP is essential when you need that guaranteed delivery, like sending an important email.
Exactly. The choice just depends on the specific needs of the application. Now, our document dives into the IP datagram. That's the actual package of data that gets sent across the internet.
Let's unpack that. What makes this IP datagram so important?
The IP datagram is like an envelope for your data, right?
Okay.
It has a header, like the address label on an envelope, which contains crucial information. Source IP address, destination IP address.
So like the shipping and return addresses, making sure the data gets to the right place.
You got it. The header also has information for like data flow control and error checking.
And speaking of addresses, how does the internet actually like match those numerical IP addresses with the human-readable domain names we use every day, google.com, all of that.
Right. So that's where DNS comes in. DNS, the domain name system. It's like a giant global phone book for the internet.
Okay, so when I type in google.com, DNS is working behind the scenes to find the corresponding IP address.
Exactly. Without DNS, we would have to remember like these long, complicated strings of numbers just to visit a website.
Oh, that'd be...
It's much easier to remember google.com.
Yeah, a little bit easier. Okay, our source also dives into routing, which I imagine gets pretty complex when you're talking about, a global network like the internet.
It does. Routing is all about finding the most efficient path for data to travel across the internet. Think of it like Waze or Google Maps, but for data packets.
Okay, so instead of cars, we have data packets zipping around trying to find the fastest route.
Exactly. And routers, those are like the intelligent traffic signals, right? Directing traffic based on real-time conditions. And they use these things called routing tables, which are essentially maps of the internet, to decide the best path for each packet.
And the goal is to, avoid those internet traffic jams we all know and hate.
Precisely. Our document mentions two main routing algorithms or ways that these routers figure out the best path. One is called vector distance. It's basically like asking your neighbors for directions. Each router shares info about the networks it knows and how far away they are.
Makes sense. What about the other one?
The other one is called link state routing. That's like having a GPS unit with a complete up-to-date map of the entire internet. So every router has the full picture, and it can calculate the absolute best path.
Sounds a lot more efficient than, relying on word-of-mouth directions.
It is. Now, when we talk about routing on a global scale, it gets even more complex, right?
Yeah.
That's where BGP comes in the Border Gateway Protocol.
Okay, what's BGP's role in all of this?
Think of BGP as the internet's diplomatic corps.
Okay.
It helps different networks or autonomous systems communicate and exchange routing information, so it ensures that data can flow smoothly between these networks, even if they're operated by different organizations or even located in different countries.
So it's like preventing data from getting lost in translation, so to speak, between these different networks.
Exactly. BGP is essential for a truly global internet.
Yeah.
Now, shifting gears a bit, our document also touches on multicast routing, which is a whole different approach to sending data.
Okay, how so?
Imagine you want to send a message to a bunch of people, but you don't want to send individual copies to each person.
Right.
Multicast routing lets you send one message that reaches all the intended recipients simultaneously.
So it's like sending a group email instead of a bunch of separate ones.
Perfect analogy. It's super efficient for things like software updates or live video streaming, where you want to reach a large audience without clogging up the entire network.
Makes sense.
So moving on from routing, let's talk about some practical applications of TCP/IP.
Okay.
Our document starts with Telnet, which might ring a bell for those who, have been using the internet for a while.
I remember Telnet. Yeah, it's a big deal back in the day.
Yeah, it was. Telnet was groundbreaking because it allowed you to remotely access and control another computer over a network. Think of it as the granddaddy of remote access tools. It paved the way for things like remote work and server management that we use every day.
So that Zoom call you took this morning,
Exacts.
you can thank Telnet for laying the groundwork.
Exactly. Then we have FTP, or File Transfer Protocol, another old-school internet protocol that's still relevant today.
Everyone's probably familiar with downloading and uploading files, but FTP is more than just that, right?
Right. FTP isn't just about moving files around. It's about doing it securely and reliably. It allows for things like browsing remote directories, managing files on a server, and most importantly, authentication.
So no sneaking onto someone else's server and making off with their files.
Not with FTP. It requires you to log in with valid credentials, making sure that only authorized users can access, sensitive data.
Very important. Security is crucial. Now, what about NFS? That sounds kind of intriguing.
NFS stands for Network File System, and it's all about breaking down the barriers between local and remote files. Imagine accessing files on a remote server as easily as if they were stored on your own computer.
That's incredibly convenient. No more emailing files back and forth.
Exactly. NFS is think of it like borrowing a book from the library.
Okay.
You don't need to know where it's physically located, you just need its title.
What a great analogy.
Right.
Our source also mentions RPC and XDR, which sound a little bit more on the technical side. What's their story?
Yeah, you're right. Those are more developer-focused. RPC, or Remote Procedure Call, is a way for programs on different computers to talk to each other and share information as if they were on the same machine.
So it's facilitating communication between different parts of like a distributed application.
Exactly. And XDR, or External Data Representation, ensures that data can be exchanged seamlessly between these different computer systems, even if they use different data formats.
So it's like a universal translator for computers.
Precisely. It ensures that data isn't misinterpreted when transferred between different systems.
Very cool. And last but not least, we have SMTP, Simple Mail Transfer Protocol, the backbone of email communication.
Ah, SMTP. Every time you send or receive an email, SMTP is working behind the scenes, making sure your message gets to the right inbox.
And those cryptic headers we see in our email clients with all the codes and numbers and stuff, those are all thanks to SMTP.
Exactly. Those headers contain crucial information like the sender and recipient addresses, the date and time the email was sent, and even the path the email took to reach its destination.
It's amazing how much complexity goes into something as like seemingly simple as sending an email.
I know, right?
Speaking of complexity, our document wraps up by looking at the future of internet addressing IPv6.
Right. And remember how we talked about IP addresses being like phone numbers for devices on the internet?
Yes. And how every device needs a unique IP address to connect.
Well, with the explosion of smartphones, smart homes, the Internet of Things, we're quickly running out of those unique addresses with the current system, IPv4.
That's a problem. So IPv6 is like upgrading from like a small town's phone system to one that can handle a global metropolis.
Exactly. IPv6 expands the address space exponentially, ensuring we'll have enough unique IP addresses for like every device imaginable for the foreseeable future, at least.
That's incredible. It's like future-proofing the internet for like generations to come.
Yeah.
But what else is different about IPv6? I mean, is it just about having more addresses?
It's more than just adding digits. IPv6 also brings some significant improvements to the table. Think of it like this. Instead of just building a bigger phone book, we're streamlining the whole communication process at the same time.
Okay, what kind of improvements are we talking about?
So for starters, IPv6 has a more streamlined header that's like the addressing and labeling information that's attached to each data packet.
So it's going from like a handwritten label with messy handwriting to a perfectly printed shipping label.
Exactly. This makes routing way more efficient. It's like having those data packets, zipping around the internet on a high-speed rail. Plus, IPv6 has built-in security features that were kind of lacking in IPv4.
More efficient and more secure sounds like a win-win.
Exactly. And on top of all of that, IPv6 is designed to better handle like the growing demands of mobile devices and the Internet of Things. We're talking billions of devices all needing to communicate with each other seamlessly.
It's mind-boggling when you think about the sheer scale of it all. But sounds like with IPv6 waiting in the wings, we're well equipped to handle whatever the future throws at us.
Exactly. We've come a long way since the early days of, dial-up and bulky computers. And as more and more devices connect to the internet, IPv6 is going to be crucial for keeping everything running, smoothly and securely.
This has been an amazing deep dive into the world of TCP IP.
Yeah.
We explored everything from the basics of networks to the future of internet addressing.
It's fascinating how all these protocols, they work behind the scenes, often without us even realizing it, to connect us all,
Yeah.
and power this incredible thing we call the internet.
It really makes you appreciate it. The next time you're, streaming a movie, sending an email, or video chatting with a friend across the globe,
Yeah.
none of it would be possible without this amazing technology.
I know, it's wild.
It really is. To our listeners, we hope you enjoyed this journey into the heart of the internet. And next time you see that loading icon, you'll have a whole new appreciation for what's happening behind the scenes.
Definitely.
Thanks for joining us on The Deep Dive.